All right, welcome back to the architecture track. It has been a mind-blowing morning at Spring One. And we're not going to stop there. I'm going to rapidly hand it off to Josh, Julien, and Layla to talk about rapid application development with Azure Spring Cloud. So take it away, guys.
Hi, hello, welcome. Welcome to our session on rapid development with Azure Spring Cloud. We're going to introduce you to the new enterprise tier from Azure Spring Cloud that was just announced a few hours ago. So that's the first time anybody does it because it was just announced a few hours ago. So I'm Julien Dubois. I work at Microsoft in the Java Developer Advocacy team. I'm here with my friend Josh Long.
Hey, my friend, how are you? Good morning, evening.
Yeah, evening for me, morning for you. Happy to be with you, Josh. And you can see that both Josh and me, we are wearing glasses. Why? Why are you wearing glasses? Layla, do you have an idea?
Maybe it's because you can't see sharp like me. Boom, boom.
Hopefully it doesn't get any worse than this. We bottomed out. There's nowhere to go from here.
And so Layla is going to be here for coding C# stuff because we can't. And thank you for joining us, Layla, also. So let's get started, get coding. Let's finish that presentation because we've only got one slide. We're going to be coding for nearly 1 hour. So here is the new Azure Spring Cloud Enterprise tier. So I'm going to create a new cluster and then we're going to play with it. Josh is going to code some Spring Java stuff. Layla is going to code some C# stuff. I'm going to deploy everything and we're going to have a look at how everything works. So I'm going to create a new cluster. So don't have a look at this. This is a dog food subscription. I'm testing something which is not released yet. It's in preview, so that's normal. I'm going to create a new service. I'm going to call it Spring 1 and keep it in H2S. And as you can see, we've got basic tier. So that was announced some time ago for Azure Spring Cloud, but we've got new tier. So that tier was what we used to have by default like last year. And now we've got this new enterprise tier for production workload. So let me select it. And I'm going to select the box here because this is something for testing. And let's have a look at this new dialog box that did not exist before. That's VMware Tanzu. So that's the new enterprise tier. We've got several new things here. So you can see we've got Spring support. So if you're using Spring, well, if you use Azure Spring Cloud, I'm guessing you're using Spring. So if you're using Spring now, you've got Spring support here directly from VMware. We've got a new build service. So we still have a build service for the basic and enterprise tier, but this one is completely manageable. You can customize everything. It uses something called build packs. So if you don't know about it, have a look at buildpacks.io. That's what Spring uses by default to build Docker images. And here it's going to be built by the cluster. So that's what I'm going to do. In fact, I'm going to just push my Java code and it's going to be built by this build service. We've got a service registry. So that's Eureka. If you've used Azure Spring Cloud before, it's the usual Eureka, but it's an enterprise edition from VMware. So let's say it's more secured and so on. And we've got a new application configuration service. This one is a bit more complex. That's why I'm going to detail it a little bit more. Traditionally, with Spring, we configure our application with something called the Spring Cloud config server. That's what we have for the basic and standard tier. Here we have the application configuration service, which works the same. So I'm going to connect a Git repository to get my configuration. It's working the same, but it's a Kubernetes service. So it's more secured, it's more powerful, and well, we're going to see how it works in a minute. So I'm selecting everything because I want to show everything. I'm going to then select one log analytics to workspace to analyze my data. This is application insights. So starting also now, we're going to have detailed monitoring of our Java application inside Azure Spring Cloud. It's not limited to the enterprise tier. You get this everywhere, in fact, everywhere in Azure when you run Java. So we will have a look at this. We will have live metrics of our application. And then I can review and create. So that's my cluster. I'm going to click on create. And well, we'll see it's going to take roughly 10 minutes to create my cluster. While this is getting created, I'm going to give back the screen to Josh, and Josh is going to code our first microservice in Java. So Josh.
Thank you, my friend.
Screen.
So now that you've kicked that off, we we started the presentation and we ran straight into kicking off the cluster. And the reason we wanted to do that is because it does take some time, but I think it's worth restating what we're doing, right? What we want is to have a platform that'll help us automate deployment into production. And so we have this really, really amazing turnkey environment built on top of Kubernetes called Azure Spring Cloud. And it's jointly developed by both Microsoft and VMware. And we're trying to make it the best place for you to run your Spring-based workloads. Hopefully you saw some of this in the keynote this morning, but if you didn't, you should know that this platform is now at least 2 years old. And we've just announced some big things today, including the enterprise tier, right? So we'll talk about that more. You already saw some of that. One of the things you have to understand is that you can actually provision the cluster in Azure. So it's just another thing that Azure offers you, and you can actually provision a cluster, scale it, and configure everything that you just saw, and then you can use it. And what better thing to use it for than to deploy and manage applications? So let's go ahead and do that. We're going to go, of course, to my second favorite place on the internet. My first favorite place, if you saw the keynote, you will know, is production. And today, as often as not, production is a cloud like Azure Spring Cloud. So what I'm going to do is I'm going to build a new microservice here, and I don't really want to spend all that much time worrying too much about the domain or the specifics of this application. So I'm going to build it just a trivial domain, trivial demo application. We're going to build an application that uses the Spring Boot actuator. It's going to use the reactive web support. It's going to use R2DBC, which is the reactive SQL data store abstraction. It's going to use Postgres, which is a SQL database. It's going to use Eureka for service registration and discovery. It's going to use Spring Cloud Sleuth for distributed tracing. And with that, I think I'm satisfied with my selection. Obviously, I've got a lot of other choices I could make, but for now, I think that'll do. So I'm going to go ahead and hit generate. And then I'll open this up in my IDE. So customers.zip. And this is, it doesn't all that much matter what IDE you use. Layla from the .NET ecosystem taught us, I think just yesterday, that you can actually use Visual Studio Code and Kotlin together, which I think is super interesting. I had no idea that was a thing you could do. But if you were using Java, you certainly could definitely easily, almost everything will support editing Java to such a level and quality that you could actually build Spring Boot applications in those tools. So Visual Studio Code, of course, is excellent for this kind of thing. IntelliJ, and of course Eclipse, and anything that supports language servers. So Emacs and what's that one from GitHub? Atom, right? Atom. They also support it. So a lot of different options here to do that'll support a competent sort of experience. But I'm going to use IntelliJ, which is, for whatever reason, not that competent these days. I love my IntelliJ, but for some reason nowadays, when I open up a new project, if the Maven dependencies on which my project depends are already resolved and locally cached, it shows that sync error when it first starts up, and that that bug has been reported. You can easily clear it by just refreshing one more time, and it just seems to, it seems to be fine the second time around. But anyway, we're going to build a new service. It's going to be an application that stores data into a SQL database, and I'm going to create an entity to manage that state. So I'm going to create an object. This is an object. And I want getters and setters and toString and hash code and all that kind of stuff. I could, of course, manually create that, but instead in Kotlin, I can use this nice little convention here to create a data class, okay? Now, this is going to have getters. These are going to have only getters, not setters, because these are immutable fields. And I'm going to map this data to a primary key, which I'll signal with this annotation here. And the repository is going to be the thing that actually looks for that. So I'll create a reactive CRUD repository. And we could spend a lot of time talking about reactive APIs and so on, but all I'm trying to do here is to establish that I'm going to create a simple API that writes data to the database, okay? Or rather reads data from the database. I'm going to create a REST controller here, and I'm going to inject in the constructor a reference to the repository. So customer repository, voila. And I'm going to create an endpoint just to return all the customer data. So I'll say, give me the customer data using the repository thusly. Okay, so I have a constructor. It defines a field, and that field is for the repository. and I use that field. I use that storage to resolve all the records and then return them, and those get turned into JSON. So this is the basic structure of my Java code. But in order for this to work, I need to create a I need to configure how this application connects. I need to configure what it looks like when it's connected and so on. So a couple of things I need here. First of all, R2DBC username and password. So R2DBC R2DBC : Postgres localhost ASC. Now I have a SQL data store. I have a Postgres SQL data store running on my local machine here, just for ease of debugging and so on. And I'm going to use this, the demo dev password that I've set up here, which I can afford to encode. But I certainly wouldn't want this to be the production credentials, right? I want to make sure that Spring will initialize my SQL database for me at all times, not just for embedded SQL databases as it would by default. And then finally, I want to give this thing an application name. I'm going to call it customers. And I think that once I've done that, I actually need some SQL to initialize the application. So schema.sql will be, Spring Boot will evaluate this file. So I'm going to say drop table customer, right? And I'll say create table customer ID serial primary key name var car 255 not null. All right, so there we go. And now I want to write some data to the database as well. And so here, after schema.sql has been evaluated, Spring Boot will evaluate data.sql. So I can say insert into customer name, and we're going to put some names here, right? These are names of people that I want to have as customers. So obviously, Julien, you're my first lucky customer. Layla, there we go. Our buddy Asir, and of course I am counted among those. So we can now restart the application, assuming that Zoom's little toolbar gets out of the way, and we should see that I should be able to hit localhost 8080 and see the instance reflected in the service registry. So 8761 is my service registry. Is it still compiling? Oh, it's the first time it's compiled anything, so it's taking its sweet time. Okay. So, hello, computer. Oh, it is not happy at all. Look at that. What have I done wrong? Keep that list down to just 500 things. Presumably some sort of syntax error. Create a table customer doesn't exist.
Oh yeah, because you put a drop table instead.
Drop table if exists. Is it like this? Is it like this? I never remember. So drop table if exists customer. So we want an idempotent drop table statement here. Okay. And presumably, I don't know. Oh, there it is. There we go. There's my service instance. It's up and running. It's accessible. And so I think now we should, talk about deploying it. What do you think there, Julien?
Oh yeah, let's deploy this to production.
Okay, good. I'm down.
I'm going to take back the screen. And so here we are. So my cluster is still being deployed because you went too fast. So I'm going to use this cluster that was already created. Yeah, it's usually taking 10 minutes, but you don't create cluster every day. Anyway.
Oh. Can you show me what that? Do you have a smiley face in your terminal, in your shell?
Yes. I got a smiley face by default.
Like the Ted Lasso of shells.
Yeah.
That's great.
So let's have a look at this cluster that I already created, it will allow us to go maybe a little bit quicker. So few things I want to show you here. So the service registry, so that's Eureka, and when we will deploy applications there, well, we will see them here. We've got application configuration service. So it's deployed now. Well, let's skip this one because I'm not going to go through too many screens. So this is new. So this is going to configure my application using a Git repository. So that's basically what the classical Spring Cloud config server does, but it's another implementation. And this is set up to go to this specific repository. Let's just go there. So it's public. So you can go there too and have a look at our configuration. What I'm reconfiguring here is the database configuration from Josh. So I'm going to use this PostgreSQL database that I created earlier with a specific username and no password. I'm not putting my password on a public Git repository. Thank you. So what's important here is, of course, a normal person will secure this. And here you will have all your Spring configurations that will be secured and versioned here. And that configuration data will be sent automatically injected into your app, here, which is called Customer. Let's have a look at my app. So I've got an app which is called Customer, and I'm going to show you how I do the database password. So you see that I'm not cheating too much.
So in order to deploy an app, you wouldn't have to recreate the cluster each time. You just create this one time, and then you just reuse that cluster. Is that true?
Yes. Let me create a new app just to see how it works. I'm going to create a new app which is called Test, giving it, 2 CPU. And I just click create, and that creates a new app. It's as easy as that. It takes a couple of minutes. And we'll see when it's created. So Customers is already created, and it's already configured. So I've got my database password, which is in my environment variables here. There are many ways to do that. You can use also something called Key Vault in Azure. There are many ways to do this, but just don't put your database password somewhere where it's available for everyone. So I've got my application, which is created, but I haven't deployed any code yet. So I'm going to deploy the code from Josh, and that code is going to create the database table and everything. Let's go here and let me use the command line. So there are many ways to deploy. We even have plugins with IntelliJ and Visual Studio Code. Well, I can show you the plugin here. But as it's a preview version, I'm not totally sure the plugin will work fine. So I'm not going to use the plugin here. But here we've got the Azure Explorer. And if you go there, you can
I think there's also a Maven plugin, yeah?
Oh, yeah, to deploy, yeah, there are many ways. There's Maven plugins, there's Gradle plugin, there's Terraform stuff also. We have Terraform support. We've got Bicep support because we're Microsoft. We've got IDE plugins, and we've got the command line. So there's like 10 ways to do it. Okay. Probably the easiest way for a demo is to use the command line. We can see here I'm saying, so easy, it's the Azure command line. I'm saying Azure Spring Cloud app deploy. So to this resource group, to this cluster, to this app, and to this subscription. So deploy the code that is inside here. So I'm not building my code. I'm just sending the code that Josh coded. I'm sending it to the cluster, and the cluster will build it. So that's what we called earlier the build service. So that's very interesting because you can also deploy, basically you can deploy stuff in 3 different ways. You can build your own Docker image and send it. You can build a jar file and send it, or like I'm doing here, you just push the source code and it works. This has got different interesting attributes. The most important thing is that it's going to be built on the server using build packs. So that means that your admins can select, for example, the JVM you use, can apply security patches and so on. So you're going to have something which is more secured and more up to date than what you would do by yourself. So it's normally a better way to do it. And it can be fully tuned on the enterprise tier of Azure Spring Cloud. So I'm going to let it build. So as you can see, it's building the jar file, building the Docker image, putting the jar file inside the Docker image, and then going to push it to the server, and then it will be deployed. Let's not wait until it's deployed, and let's go to our second app. So we get fast and we can see more things. Second thing we want to do, so Josh created a Java file, a Java project. Layla is going to do the same thing with .NET. And I've heard that it's working the same thing in .NET as in Java. So that's pretty exciting. Layla, can I give you the screen?
Of course you can.
Okay, here you are.
Awesome. Right. Let me share my screen. And there we go. So as a .NET developer, we're not going to be using Spring. We're going to be using Steel Toe, which brings you a lot of the functionality that Spring does. And this is going to look really familiar compared to what Josh just did. We have an initializer here in Steel Toe as well. And Josh has already given me sort of some database structure and API structure that he wants me to return to his app. So we're going to go ahead and code that up now. So just like in the other initializer, I can set up orders here. We're going to use the latest version of SteelToe, which came out just a few weeks ago. And Azure Spring Cloud supports .NET Core 3.1 because that's a long-term support version. And I think we're getting an upgrade coming January to be confirmed. So we need this to be 3.1. Now we're going to add a couple of dependencies here. The first one is going to be Eureka, because I'm going to show you how you can easily connect an app to Eureka. We're also going to need hosting. And those are the only two things that we're going to need for now. So I'm going to click Generate. And then we're going to take this down into the command line. So let's go and have a look. Let me minimize that. Oh, just before I do that, I want to show you that I've got Eureka running locally. You can see there's no instances here. There's no trickery. There's nothing happening. So Josh gave me that, and there it is running locally. So if we come over to the downloads, that's where my orders has just gone to. So I've just got this nifty little thing. We're just going to unzip it into the correct repo. So if we ls in here, you can see I've got my orders. So oh, hello, go away. I am just going to cd into orders. And then I'm going to open Rider. So I'm using Rider today. You could use Visual Studio Code, Visual Studio. And yeah, let's open that as a directory. Okay, there we go. So I'm going to give you a quick tour around this application. So if I come in here and have a look at our CS proj, you can see that we have, let me make that much bigger. We've got our SteelToe version, Net Core App 3.1, and then we've got our two NuGet packages that came with our template. Also with our template, as with most .NET projects created from a template, we have weather forecast. We don't need that. We can delete it. One of my favorite things is deleting code. And we also have a weather forecast controller. Well, we're not talking about weather forecasts today. We're talking about orders. So again, I can delete that. Now, just before I continue with anything, I want to show you some of the other things that the template and initializer have added. If we go into the program file, you can see it's added this line here, use cloud hosting. And if I go into the startup, it's added in the middleware already for us. And this is kind of the default configuration. There's a lot more settings that you can do with it, but we have the services.add discovery client, and that's going to do everything for us to connect to Eureka. We don't need to do anything else at this point. So we've got that. Now we're just going to create that endpoint. So I'm going to create a new controller. So let's go ahead and do that. This one's going to be orders controller. And we're going to zoom in. Now, this is a view controller. We don't want a view controller, so I'm going to get rid of some more code. Yay, I love deleting code. It's so much fun. So the first thing I want to do is make this into an API controller, and I'm going to give it a root. And Josh and Julien have told me the root they want, which is not # orders. Now, we also need an order object, because we love our objects. So I have some quick shortcuts because no one wants to see me fudge all of my keys as we go. So if I bring in the usings now, I have this nice little order model here, which just has an ID and a customer ID. And I'm using system.json, system.text.json to give when it's serialized, the right JSON property names, ID and customer ID. So that will do it all for us. So if we come in here, the next thing I want to do is a quick method that randomly generates a whole load of orders when it receives a customer ID. So I have redone that as well, because again, you do not need to see me going through that. So if I just bring in all of my using statements, you can see that this takes a customer ID, generates some random orders, and spits out a collection of random orders with an ID and a customer ID. The last bit we need to do is the actual endpoint. Because this is an API controller, I can use my verbs. So this one is going to be a get. I'm going to give this another root definition, which is going to be a little bit of a nullable one. So in here is going to be customer ID, because that's what Josh's app is going to pass us. And I'm going to make that nullable just in case. Excuse me. So this is going to be a public, and I'm just going to return a list of order, and that will be a get. And I'm expecting an int of customer ID there. So that's that bit. And now I've set that up. All I have to do is just return random order and pass in that customer ID that we got there. So that's nice and straightforward, hopefully. And I'm going to hit play. I've got my Eureka already running. So if we go and run that, hopefully everything builds. It looks like it has. So if I just minimize this window, and hopefully if I go into Eureka, we can see, yeah, there it is. It's registered. And if I just go and check in here, refresh the page, hopefully we can see right there that it has registered itself with very little interaction from me. And that's how quickly you can get a .NET app connecting to Eureka, and hopefully we'll see it deployed or some sort of deployment to Azure Spring Cloud momentarily, and that's all using Steel Toe. So I guess, Julien, we're back over to you now, yeah?
Yes,
I'll
thank
stop
you.
my share.
Whoa, thank you, sir. It's back to me. So my Java application deployed correctly. So I've got some JSON output saying everything succeeded. You can see succeeded here. Oh, sorry, I'm not sharing my screen. Sorry about that. Sorry, so here is my output from the command I just gave to the command line. And we can see it was deployed to the enterprise tier and that it succeeded. So if I go here to apps and I go to customers, well, it succeeded. It's not, it's a microservice, so we're going to access it afterwards. We need to first code a gateway. Well, Josh is going to code a gateway to access this. But here we can see that my Java app is deployed. I created another gateway to do the same thing as what Leila did, but I haven't deployed it yet. So we can see we've got a running instance, but it's a test instance, so there's nothing. What's important here is to see registration 0, so it's not registered. So I have deployed the Java app, but not the .NET app. It's not that I don't like you, Leila. It's not that I don't like .NET. It's part of of what we want to show. Josh is going to create a gateway that connects both microservices. And well, it's fun to show when everything succeeds, but it's also interesting to show when something fails. So I didn't deploy it on purpose. So we're going to have some failure, and we're going to have a look at how the enterprise tier of Azure Spring Cloud manages that and monitors it. Oh, by the way, I just forgot to say, if you want to deploy your .NET app on Azure Spring Cloud, it's something as Java, you can build it. So it builds a DLL, from what I understand, and you push it, something as a jar file, or you just do like I did for Java. I pushed the Java code. You just put the .NET code and it's going to build it and run it for you. So same thing. So in order to be able to access those microservices, well, access Java 1 and fail to access the .NET 1, we're going to need a gateway. And so I'm giving back the screen to Josh, because Josh, you're going to build a gateway for us. Is that correct?
All right, good stuff. So thank you for that. So we have now a customer service with a lowercase c, and then we have an order service with a capital O, and it's fine.
Yes, you're wrong, Josh. You're wrong. Remember, you're the wrong one.
That's true. I'm gonna. It's fine. The world's fine. Anyway, we've got our two microservices, and happily they shall coexist in production. But I don't want to give direct access to each of these constituent microservices to our outside clients. So I tend to, as is my habit, introduce a gateway, right? And so we can, this is one of those things that you can actually do. Is it already there, or will it be there? Is it Julien? Is it?
I've already got a gateway. Well, it's created, but it's not running.
Okay, so, but I mean, is that in the enterprise tier?
Oh, sorry. You're removing all the fun. Yeah, what you're going to do is for nothing. One of the new stuff of the enterprise tier is that we're going to have a commercial edition of Spring Cloud Gateway. So currently, it's not ready yet, not in the preview. So you need to code it like Josh does and what you do in the standard tier or basic tier. But very soon, in the enterprise tier, you will have a commercial edition of Spring Cloud Gateway. So everything that Josh is going to code will be useless because it will be provided out of the box by Spring Cloud, by Azure Spring Cloud.
Right on. But in the meantime, we can get some of that power just by using Spring Cloud Gateway directly. This is also a good chance to demonstrate, some of the nice features of reactive APIs, namely that it supports easy scatter, gather, service orchestration, and composition. And so what I'm going to do is I'm going to create a gateway service here, a configuration class. Let's see here, configuration class, CRM configuration. And in that class, I'm going to define a Spring Cloud Gateway. And you do that just by creating a bean that returns a route locator. So I'll use a route locator builder, and the route locator builder will be, I'll use this nice Kotlin DSL that comes for Spring Cloud Gateway to make the work of creating a gateway even easier. So if you've ever done it in Java, you know that it's as trivial as it can get given Java. But with Kotlin, we can go just a step further. And so the structure of a Spring Cloud Gateway application is that you have routes, 0 to n routes, where each route can have a predicate. And so in this case, I want to describe a path. I want to match a path coming into this service on a port, which is, let's say 9999. And I want to give it a Spring application name. And I'm going to call this gateway. So when a request comes in to localhost 9999/proxy, this will get matched. And then I want to take that request, that incoming request, and forward it onto the customer service. Okay, so I've got the customer service running on my local machine in the service registry. It's discoverable through the service registry. And that'll work just fine, right? That'll be okay. But the problem is that proxy, this path, doesn't exist as such on the customer service, right? So what I need to do is I need to actually use a filter here to swap out the incoming path and replace it with customers, which is a known path that exists under the customer service, right? So this is a very trivial gateway, but it does work, right? And now I also want to have the order service running that Leila just finished up. So I want to go here and I'm going to run that cd orders net. And I'm going to do .NET. No, actually, I think do I have it already running? No, I don't. Okay, so .NET run and go. Okay. This worked a minute ago. Yes. Okay, good stuff. So localhost. Sorry, I don't even need localhost. Let's just go to the registry to confirm that everything's okay. There we go. So our services are there. Both of them are just fine. Now I want to be able to. I've got a gateway, and this is kind of like a proxy. What I want to do now is I want to actually create an API adapter, and that's going to use reactive APIs to interact with the downstream service. And I'm going to use the reactive non-blocking HTTP web client. In order for that to work, I need to create that client, right? So I'll create a bean like this, and the web client. In order to create it, I need to have a web client builder. Thusly, so web client .builder. .build, okay, and in order for that to work, I want this thing to also understand how to do service registration and discovery. So service registration and discovery. So what I'm going to do is I'm going to actually create the web client builder bean itself, and I'll annotate it with @load balanced, right? So this is going to plug in an interceptor that will understand what I mean when I give a host name that matches a service ID in the registry, so customers, orders, etc. So this prefix means load balance. This is the service ID. This is not DNS. Okay, so that's my Spring Cloud Gateway code. Let's also create a reactive endpoint that composes the data. We're going to do scatter, gather, sort of service orchestration and composition. I'm going to do that here with a CRM client. Okay. So class CRM client and private val HTTP web client. All right. Now, first things first, I want to get the customers, don't I? So I want to say this.http .get URI. And here too, I want to use the service ID, not the host and port. So I'll use, because I've configured an interceptor to support service registration, this will just work. The data that I get back, I want to turn that into a stream of customer. So I'll use reified generics here, sort of, pseudo reified generics. I need a client-side representation of that type. So obviously I'm going to go to the service type here, and I'm going to do something terrible. Again, something you should never ever do ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. And there we go. So there's my customers proxy and my endpoint. Now I want to do the same thing for the orders endpoint. Here, of course, I don't actually have a service I can just copy and paste from, probably for the better. So I will just I'll just do it the old-fashioned way. Okay, good. So there's my order type and my customer type. And remember, these are two different microservices. A customer has orders, 0 to n orders. It's a question about modeling. Maybe one is a bounded context, and one is one part of the aggregate of the other. And I imagine that in a real production environment, both records would continue to exist even if one side or the other was deleted. So I keep this as a separate thing. So this .http.get.uri http orders, and I want to get the orders endpoint. And I think it takes an ID, right? Is that true?
Yes, it does. It takes an ID.
Okay, so I'll take retrieve, and I want to get the stream of orders. And voila. Okay, there's my stream of orders, and I have to actually pass in the parameter there. And that'll come from here. Good. So now, whenever I want to get the reactive stream of orders, I can just call that one. I want to get the customers, I can call this one. And what I want to do now is to take both streams of data and compose them into one view of the data. So I'm going to create a composite type, an aggregate. So it's going to be called customer orders. And I'll have the customer, and I'll have the orders. Seems reasonable. List of order. And this will look like this. Custom orders equals this dot customers dot flat map, and here I want to create a tuple. I want to store in memory the reactively resolved customer. So for each customer in this reactive stream, I'm going to visit it using this flat map operator, and there's an implicit variable called it. So I'm going to store that in a kind of a named typed array where each element can have its own unique type. That's called a tuple. Okay, so the first element will be a reactive stream of customer. The second element will be the orders for that customer, right? So orders it.id, and I'm going to collect all that into a list. And so now I've got a tuple. If you look at this thing right here, if you look at the next type, the thing I'm using here, it is a tuple 2. It's a type called tuple2, and it has a field called T1 and another one called T2. And so T1 corresponds to the customer, and T2 corresponds to the list of orders for that customer. So I can, given that, I can actually just map that into an aggregate type, right? So it.T1 and it.T2. Okay, good. So there's our aggregate. And I can now use this. I want to actually just create another HTTP endpoint here. I'll just create a controller. So at REST controller class customer orders private val CRM client. And I'm using HTTP because why not? I'm using REST. But as we just talked about this morning, you could use GraphQL, right? You could do some really interesting things here. It doesn't have to be REST. You could use RSocket, right? You could do all sorts of things here. Okay, so there we go. There's my simple endpoint, and I'll make this available whenever somebody goes to COs. Does that look right? That looks good to me, I think. So I'll go ahead and make sure we've got the properties. Let's kick it off. Now, this is going to talk to both services, one .NET, one JVM Kotlin, right? And it's going to give me a view of the data through the proxy, and it'll give me a view that I'm going to compose. Now, obviously, in our production, for the purposes of this demo, we don't have the order service. So, when we invoke this service, pay attention, because this is the only time you'll see the whole thing working for now, right? Okay, so localhost, what did we say here? 99.99, is that right? Yep. COs. Okay, there we go. So we've got a customer and we've got orders for that customer. Got a customer and orders for that customer. And again, the endpoint there that Layla built just returns a random number of orders. So given a customer ID, we just want to synthesize some orders so that we can see what it looks like. But you can see that it's all for the same customer, right? So customer ID 1, customer ID 1, etc. Good, so that's working. Now what about the proxy endpoint? Well, again, thanks to Spring Cloud Gateway, that was trivial to set up, and that works as well. All right, I think we've got a gateway now.
Awesome.
What do you think?
It looks awesome. I'm very impressed to see that, well, everything that you can code in such a little time. And I think it's great for people to see that they can use a microservice in Java, a microservice in .NET, compose them with a microservice also in Java, and that everything works together in a unified way. And so whatever the language or the tool that you want to use, well, you're supported by Azure Spring Cloud. So let me share my screen again, and let's have a look at how we can deploy that gateway. So, sorry. So those are the logs from my previously deployed app. So I'm going to kill the log. I'm going to go to the gateway, and I'm going to do the same thing and deploy it. So same thing as before. I just do Azure Spring Cloud deploy with the gateway, and I'm going to push the code, and it's going to be built by the build service, and so on and so forth. So all of this should work. This is going to take a couple of minutes. So I'm going to now show you what we are deploying this to. So we've got different apps. So we've got 4 apps because we created tests earlier just to show we could create a test. So this one is not really working. We've got customers, so the Java app that works, orders, the .NET app that doesn't work, and the gateway, which is being deployed at the moment. And the gateway has got an endpoint which is assigned, so it's available on the internet. The others should not be available on the internet. That's the whole point of microservices. They're hidden, there's stuff that work on. But the gateway here is available on the internet and is opening up routes to those microservices. So that's the first thing I wanted to show. Second thing I wanted to show quickly, just to show exactly what we're doing, is PostgreSQL, because it all comes from PostgreSQL. We've got data coming from PostgreSQL. So you remember Josh created a SQL file earlier. Sorry, here it is. He created a SQL file earlier to create some data, and we deployed. And so if we go to PostgreSQL, well, it created in our schema, it created one table called customer where we've got our customer. So we're going now to have a look if all of this works together. Well, if my data is in my database, we can guess that the microservice deployed correctly. But then we need to see if the gateway connects to the microservice, which connects to the database, and all of this works together. Let's have a look at what it's deployed. Well, I guess we can curl it now. So I'm going to do 2 curls. So the first one is on the proxy. So that's what Josh did, and that connects to our Java microservice. So this one should work without any issue. Yes, and it's giving back data from our database. So we know that our microservice connects to the database and everything is working fine. So that's cool. Second thing that we want to do is connect to that aggregate route, which will not work. So I'm going to call it. And indeed, we've got a 500 error message, internal server error, which is bad. And so as a developer here, so I can see everything is working, but it's quite limiting to do curl requests. So let's have a look at the monitoring capabilities of Azure Spring Cloud. And for this, I'm going to go directly to something called Application Insights. So it's another tool for monitoring applications. And so it's very complete. There are lots of stuff. As we've got only 10 minutes, I'm just going to focus on the most important ones. So the first one is live metrics. So this is new. This is arriving to everybody who is running Java on Azure, including Azure Spring Cloud, but not limited to Azure Spring Cloud. And so this is monitoring our application live. So we've got a Java agent that instrumented our app. And without doing anything, as you saw, we just git push the code. Well, my app is instrumented, and we can have a look at it in real time. So let me just do some curl requests at the same time. So, oh, sorry. So we can see some requests arriving. As is a request, yeah, good request, good request, good request. And we can see here, we should be able to see the request arriving here. And then we can see also our service here. We can see the customer service and the gateway service. And most of them are having a few requests per second. Well, not a lot, I'll just click quickly. And we've got some requests here arriving. That's the first thing. That's just to have a look live at what's happening in my cluster. Then the most interesting part is the application map. So again, we didn't do anything. Here we are the request, by the way. If I go to the application map, without doing anything, but the only thing that we did is that Josh selected Azure Spring Cloud Sluice when he generated the apps. So thanks to Sluice, our apps have got automatic tracing on them, and they are automatically instrumented by Azure Spring Cloud. So when you deploy an app to Azure Spring Cloud, that app automatically is seen here and is instrumented. And this is going to show us what's happening in our cluster. And I don't see the errors. We should have some errors. I'm going to push them. So this is, of course, a batch. So you're not having them live. You need to wait a little bit to refresh. Well, let's have a look at the calls that worked, and then we'll have a look at the calls that didn't work. If I have a look here, I can click on my instance, view. Oh, well, let's have a look at this a little bit later, because we can see some errors here. We can go to the details and see what's happening. What's interesting here is we can see what is slow, which requests are slow and are working, but you still want to investigate performance and have a look at why this request is slow and what's going on. And you can also have a look at what's failing. And if it does not refresh on here it is. Here we've got an error, so that's probably the error I did earlier. And if I click on my error, I'm going to be able, well, to see my issues and detail exactly what happened. So let's investigate the failure. So again, in real life, you're not going to investigate the failure like 10 seconds after they happen. So this is a batch, and that's normal. But here, just for the demo, you can see that few seconds after having the error, you can click on it. It's telling you, okay, you got that error. Oh, and that error is this one. And you even got the stack trace. And the stack trace is that I got a 503 error from order 1, which is what Josh coded. I've even got the stack trace, so I can know exactly what happened. So what's interesting here is that as soon as I've got an error, well, I can just drill down. I've got the stack trace. I've got the error. I can understand what's happening because the issue that many customers have told us on Azure Spring Cloud is that they're deploying hundreds of microservices, well, several gateways also. And it's very complicated when you get an error to drill down and understand what the error is and why did you get that error. And here, with that tool, well, without doing anything, you got a graphical view where you can drill down and better understand all the errors that you got and of course, improve everything. You can also see when you've got some correct requests arriving, you can see why they are slow. You can also instrument your database. So you can have a look at your SQL code and know that maybe you did a SQL request which was not optimal. Maybe you're missing an index or something. So this is extremely important if you want to better understand what's happening in your cluster. And it's a very important tool for production use. Again, Azure Spring Cloud is all about production. So we're giving you all the tools that you need in order to better understand what's happening inside your cluster. I think that's all that I wanted to show for application insights. We've got a few slides just to wrap up. Except if Josh or Leila, you've got some last words on what we just did.
I love that there's an option here for turnkey development and production worthiness. Like it blows my mind that we just created a cluster and we're able to get a whole system of services up and running, including databases and monitoring and observability and all that stuff in the scope of one little talk at Spring One. That's the dream. That's what you want. You did like, and that was despite our cheesy jokes. We still got it done in that time, right? Like, can you imagine if what somebody focused on the keeping their eye on the prize could do in even less time? It's amazing.
Yeah, thank you. So just to wrap up, sorry, just let me show our faces again. If you want to discuss with us or learn more about Azure Spring Cloud, please, come and see us. You can follow us on Twitter. So my Twitter handle is @Julien Dubois. Josh, it's @StarbucksMan, I think.
BUX, yeah.
And Leila, what is your Twitter handle?
Leila codes it.
Leila codes it.
Very easy.
Yeah, I should have remembered it.
You should have, but never mind. You remembered a lot already.
I'm following you, so it auto-completes. So that's why that's Leila and it's you. And for Josh, it's fun because Starbucks. Because you don't sleep enough, probably. If you want to have more information about Azure Spring Cloud and the various tools that are around Azure Spring Cloud, we've got a lot of sessions at Spring One. So here we have listed the most important ones. There are two that I want to point to. So on the left, the third session, there's a workshop on Azure Spring Cloud. It's an extremely good workshop because I wrote it and it's done by my team. So it's excellent people doing an excellent workshop. It's a workshop on the normal Azure Spring Cloud. So you won't have the enterprise features, but what we just saw is that the enterprise features basically work out of the box. So if you know the normal Azure Spring Cloud, you know enterprise Azure Spring Cloud. And the second one I wanted to highlight is the one at the bottom right, which is a panel discussion with our Azure Spring Cloud customers. So those are some of the people already using Azure Spring Cloud. It's a discussion with them, with our good friend Azure. So people who really know Azure Spring Cloud very well because they're using it in production. So if you're interested by Azure Spring Cloud, that's probably where you want to go. If you want to learn more about Azure Spring Cloud, we've put in here some URL where you can learn about Azure Spring Cloud. Or you can, there's a workshop, by the way. It's at the middle one on the top. So that's a workshop, so you can do the workshop by yourself. We've got also, we've got a learning path for Java on Azure. That's my T-shirt, by the way. That's Microsoft Learn. So it's a great place to learn about different technologies, including Java and Azure. And last thing, if you want to try Azure Spring Cloud Enterprise Edition, here we've got, on the left, we've got a QR code. So you can just go there and register and you will have access to our private beta. So you can do exactly like we did and play with it. Again, it's a private beta, so it's not open to everybody. And there can be bugs. We're still, finishing it before releasing it. But it's very interesting if you want to test it before it's released. And that brings me to my second QR code on the right. If you have some thoughts, any issue, anything about Azure Spring Cloud, please go there and tell us what you think. You can win a prize worth up to $150. But don't do it for the money. Do it for the love of Spring, of course. I think we're just on time. We have 3 minutes left. So if you want to join us afterwards, there's a Q&A session where we'll all be going. So that's another Zoom meeting. And that's it for me. So thanks a lot. Josh, Leila.
Thank you.
Thank you.
Leila, Julien. And thank you everybody else joining us.
Thanks a lot.
See you soon.
Yeah, see you in the Q&A. And thank you, Josh and Leila, for this wonderful presentation.
My pleasure.
Thank you, Josh, Julien, and Leila. That was an outstanding talk. Be sure and join the Q&A session to continue discussing Azure Spring Cloud. In fact, that topic and Azure Spring Cloud Enterprise and all that actually coincides with a talk I'll be giving a little bit later today. Speaking of which, I am going to leave my MC chair for a few hours, go continue putting the final touches on my talk, and then I'll see you back in this track at the end of the day. But I'm going to hand it off now to Ivan after the break to introduce our next set of speakers. So I hope you have a great time at Spring One for the rest of the conference, and see you later.